All right, here we go with chapter 9, our last chapter. We're going to do 4 sections in chapter 9. So we'll do 2 and 2. So the first 2 are going to be is counting and probability, and then we'll take a quick little quiz on that, and then we'll do 2 more sections and take a quiz on that, and that'll be it for our 4th quarter grading. So here we go with section 9.1, basic combinatorics, which just means counting. Okay, we're going to count. We're going to count large sets of numbers, though, however, so it's not super easy. It's PreCalc, right? Okay, so here we go. How many 3-letter codes can be formed using the letters A, B, C, and D if no letter can be repeated? So you use the one letter just one time. So, of course, you can just kind of count them out. So what if I put A first, B second, then I could put C. If I do A first, B second, then I could do D. I can't repeat anything. So then I could do, what if I did A and C first, and then B? A and C, then D. So I could kind of list them out, but the listing gets long, especially if you have more choices, and it's easy, and sometimes you're like, oh, what if I forget one? But if we did this nice and neat, we get 4 rows of 6 or 24 possibilities. Okay, so you can do that. It's tedious, but it's a possibility if nothing else works, right? Here's a diagram called a tree diagram, kind of just visually showing the choices. So I have 4 choices, okay, for that first letter. And then I can go to second letter. So if A is first, then I have 3 choices for the second letter. Okay, so if I do AB, then I have 2 choices for the third letter. If I do AC, I have 2 choices for the third letter. AD, 2 choices for the third letter. So it gives us each branch gives you a possibility. So you get 24. Okay, so that's the tree diagram. And these typically are not the choices that people make in solving these kinds of problems, but there's a possibility of doing them this way if you so choose. This is the problem-solving strategy that most people choose, but it's called staging, right? So we have stage 1, pick the first letter. Stage 2, pick the second letter. Stage 3, pick the third letter. And so if a procedure has a sequence of stages, okay, stage 1 can occur in R ways, stage 2 can occur in R sub 2 ways, and so on. Then the number of ways that the procedure can occur is the product of each of those. So here's the deal. I need to pick a 3-letter code, right? So that first stage, okay, if we through staging, is to pick that first letter. It can be an A, a B, a C, or a D. So I have 4 choices. Okay, then it says I'm going to multiply it by what can happen in stage 2. In stage 2, the letters can't repeat, so I need to pick my second letter, right? That second letter now has 3 choices. If I already chose A, then I only have 3 choices left, B, C, D. Okay, so there's only 3 choices left. Okay, and then third stage is to pick the third letter. Okay, of course we are taking the product here. That third letter, if I've already picked 2 letters out of the 4, then there are only 2 letters left. So 4 times 3 times 2 is 12 times 2, or 24 different ways. So staging is the way that most people would choose to solve those first couple of problems, rather than doing the diagram and listing those all out. So what can happen first, second, or third in this particular case? All right. Here's an example where we can use the staging idea. So a license plate has 4 letters. So stage 1, stage 2, stage 3, stage 4, right? The 4 letters. Followed by 3 numbers. So 1, 2, 3. 3 numbers. Okay. So stages, right? Each one of these entries is a stage. Find the number of different license plates that could be formed if there is no restriction on letters or digits that can be used. So that means no restrictions means if I put the letter S here, I can put the letter S there, right? I can do S, 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 S if I wanted to. No restrictions. We just have to have letters first followed by numbers. And so we'll just use the staging formula. We're going to multiply or take the product of each stage. So since there are 26 letters in the alphabet, I have 26 choices in stage 1. I can pick anything I want to again. It just has to be a letter. 26. 26 letters to choose from because they can repeat, and 26 letters to choose from here. Okay. Now numbers, I can include 0. There are no restrictions, right? So 0 to 9, that's 10 digits. 10 digits, no restrictions. So there we go. We multiply that out, and you end up getting a lot of different license plates. 9, 7, 6, 0, 0, 0. So there you go. What if it were a 7 blanks, whatever, but it could be numbers or letters in any of them. So if we still have 7, 4 followed by 3, still have 7, but these could be letters or numbers, no restrictions. So this one could be a letter or a number, that could be a letter or a number, that could be a letter or a number. How would this be different? Okay. So it could be any of the 26 letters, any of the 10, so that I have 36 choices, and 36 choices, and 36 choices, and so on, right? So just a different way of interpreting that, rewriting that problem so it's different. All right, so second example there. Okay, so permutations of an n set. This is called factorial, so this is n factorial, and I'll just explain this in just a little bit here in this example. So count the number of different 8-letter words using that. It doesn't need to make sense, so it could be just mix those up and in like a word. That can be formed using the letters in the word computer. Okay, so I'm gonna have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 different spaces to fill, right? 1, 2, 3, 4, 5, 6, 7, 8. So I can use my staging, okay? And we are using just those letters, so we're not gonna repeat those. That's the implication here. So I could put any one of those 8 there. So I'm gonna use the staging idea, okay? And then I have to pick a different letter. I'm just going to use those letters and do 8-letter words. So then I would only have 8 choices for the second letter. Okay. Then I'd have 6 letters to choose from. Then I'd have 5 letters to choose from, and 4 letters to choose from, and so on, all the way down to that last choice. So just be whatever letter is left. Okay. This, of course, if you multiply that all together, gives you 40,320. This is called a factorial. When you take a number and you multiply it by every other number below it to 1. And so if you don't want to type that all in, 8 times 7 times 6 times 5 times 4, it's fine here, you can do that. But you can use the factorial button on your calculator, okay, which just shortens that up. Because what if you had 28 things you needed to order? You don't want to type in 28 times 27 times 26 times 25. And so here's where you're going to find that factorial button. We'll grab our calculator. All right. And we'll turn this on. Try to get this into the camera here. What you are going to do is type in 8. So 8. And then factorial you will find under math and probability. So hit that math button, sorry, right there, math. And then probability is all the way over here to the right, so I'm just going to arrow over to the right to hit probability. Factorial is choice number 4. So I'll just hit that. And you'll notice on your screen you get 8 with a little exclamation point and hit enter, 40,320. Okay, so that's where you're going to find the factorial button if you don't want to type in that string of numbers. Okay, so just a little shortcut. It's certainly okay to type them in. Of course, you get the same answer. All right, so that's called a factorial. Distinguishable permutation. So the word computer had all different letters. What if the letters you're choosing from are from the word Mississippi? Okay. Is it different if I put this letter I first, or if I put that letter I first? Does it make a difference? Okay. notice the letters are not different, or some of them are, but not all of them. So you can't really distinguish between putting that letter I first or putting that letter I first. So this is a special situation, okay? So if these letters were all different, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I would just say, oh, there's 11 factorial ways I can arrange those, okay? But they're not all different. So I need to be able to distinguish between them. So what I do is I take my 11 factorial, I have all those letters, and then I'm going to divide out the ones that are indistinguishable, okay? So I have n sub 1 objects of a kind, the first kind. So I have i's, 1, 2, 3, 4 i's that are indistinguishable. So I'm going to divide those choices up because I don't know if it matters if I put that I first or the other I first. Okay? Then I have another set of s's that I can't tell. And if I put that one first or put that one first, it doesn't matter. Or that one or that one. So I'm going to divide by 4 factorial for the s's. Okay. And then I have p's that I can't tell apart either. So I'm going to divide by 2 factorial for my p's. Okay, so make sure when you type this in, you're taking 11 factorial divided by all this, so just put parentheses around that, okay? And then you can, especially for 11 factorial, you'll want to go to the probability, or go math, so to 11, then hit math, arrow over to probability, and then hit factorial, which is choice 4, divided by parenthesis, 4, math, probability, hit that factorial key, choice 4, times 4 factorial again, math, oops, sorry, I messed that up. Oh no, I messed the whole thing up. 11, how about I just grab the answer so I don't waste your time? I don't have it on my answer sheet. I apologize here. Okay, I ended up getting 34,650. So hopefully I typed that in correctly. 34,650. Okay, so sorry about that delay. Okay, so that's if you have things that repeat and you can't tell them apart, use this idea. They're all different, and it doesn't matter. Just count them up and put the factorial key behind it. All right, what else do we got? Permutations and combinations, the last 2 ideas. So permutations are if you're ordering objects and the order makes a difference. Order or order matters is another way that you'll hear people say that. Okay, so like if you're dialing a telephone number and, you know, so 420-4976, okay, that's different than 420-4796, right? The order of those numbers in that telephone number matters. You're going to get 2 different people if you call and the numbers have a different order to them. So telephone numbers would be a permutation, because the order in which you put the numbers is going to make a difference who you get a hold of on the other end of that telephone line. Okay, so we use something called a permutation. This is the actual formula for it, but we're not going to worry about that because our calculators have a permutation button. Okay, so let's say I'm going to choose, and I think we have this example in your notes. Okay. So, nope, we don't, so I'm going to add it. So what if I want to choose from 10 people, I want to pick a vice president and a president, okay? So I have 10 candidates, and I want to pick a president and a vice president, okay? So it does, the order here is going to make a difference. If the first person I pick is the president and the second person I pick is the vice president, it doesn't matter. If I pick Peter first, followed by Sam, then Peter would be president, Sam would be vice president. Okay. If I picked Sam first, followed by Peter, then that makes a difference in their roles, right? So the order would make a difference in the outcome. So that would be called a permutation. And all that I need to do, I don't need to use the formula. I just need to use that notation. I have 10 people, and I'm going to pick 2. Okay, so you're going to go back into that same menu, math, over to probability, but type your 10 in first. Okay, so I will show you what that looks like. Okay, so you've got 10 on your screen, on your calculator screen, and then you just go over to math, all the way over to probability again, and then choice number 2 is NPR, right? I've already typed in the N, 10 people, and then I'm going to hit that button, which is choice number 2, and then I want 2. So I have 10, I'm going to choose 2, a president and a vice president. Okay, so that gives me 90 choices. All right, so you don't have to worry about the formula on the notes. Just use your calculator. Okay, type that in. So this is under math, and then you arrow all the way over to probability, and then you pick choice number 2. Okay, is how you get that. All right, so that's called a permutation. There is a situation, well, what if I don't care if I pick a president or a vice president? I just want to pick some people. Okay, what if I want to pick a committee? They don't have a specific role. Okay, that's called a combination. Okay, so the order doesn't matter, or you're just picking a group. Okay, so choosing a group of things is the situation here. Again, there's the formula, and that's not super important. We just want to be able to use that button. Okay, so what if I have, in this particular case, oh, we do have an example coming up, so that's fine. But if I had 10 things, 10 people, and I only want to pick 2 people for our committee, then I'll do 10 choose 2, okay? Then get an answer using that button. But we have one more example here, so we'll just use the example in the notes. Okay, so I have 10 people. Oh wait, how many, no I don't, I have how many 10-person committees can be formed from a group of 20 people? Okay, so it's a committee. That's the word that's going to tell you. The order doesn't matter. You're going to pick the combination. So it's the C one. I have a total of 20 people, and I'm going to pick 10. Right? So that's all that's really to this. Grab that calculator. Type in your number first, 20. All right, and so we will, oops, let me get you on the screen here. 20 math all the way over to probability, and then combination is choice 3, and then so it tells you combination. I have 20, I'm picking 10, and then hit enter. So quite a lot, 184,756 different groups of people. But just try that, make sure you are able to find that answer on your calculator. Okay, so that is it, I believe. We have permutations, we have combinations. Permutations is the order makes a difference, like a phone number, okay? Or picking a president, vice president, secretary. They have a specific role. If it's just a committee, then that's a combination, okay? This we're not going to need to worry about for us anymore. And here is the shortened version of that assignment. There's, what, 6 questions to take a look at. So it'll be this section and one more. We have counting. And probability, it'll be our next section. So we'll try that one out next. Thanks.